Okay, I've started recording. So yeah, as I said, we'll take one problem, which is a relatively simple problem. I think it's a common problem that I've seen in multiple interviews before. And yeah, as I said, once I pose the problem, you can ask me any clarifying questions, and then we can discuss possible solutions, and then you can proceed to code. Right? You'll be coding in C++, right? I've selected C++
Yes.
here. Okay. Okay. So we'll get started.
Yes.
Yeah. Okay, so let's say in this problem, what we are doing is we are redefining the order between, so let's take the English alphabet. We have 26 characters, right? What I'm doing here is I'm redefining the ordering of these 26 characters. So if you see on line number 4, I've defined this string. I've given you the string of 26 characters, which redefines the ordering of these characters. So the smallest character now is H, right? And then you have L, and then A, B, C, D, E, F, G, and so on and so forth, right? So in this redefinition of the alphabet, H is the smallest. So in your regular alphabet, you have A, B, C, D, right? So now I've redefined. Now that I've redefined it, the alphabet starts with H, L, A, B, C, D, E, and so on, right? So given this redefinition of the alphabet, I will give you a list of words in this hypothetical alphabet, and I want you to tell me whether the words are in sorted order or not. So are they alphabetically ordered or not, right? So I want you to write a function that, yeah.
Yes, please continue.
Yeah, so I want you to write a function that takes in a list of these words, and it also takes in this string order. So if you see on line 12, I have this function that takes in 2 parameters, right? The list of words, and then you have this string order, which tells you the ordering of the characters in this hypothetical alphabet, right? And I want you to return a Boolean which tells me whether the list is sorted or not.
The list being sorted means that every this high word, this word mojo, so every word in this word array, that should be sorted according to the
yeah. So what this means is, so are the words in alphabetical order or not? So I have 2 words in my list here, high and mojo, okay, right? So are they in alphabetical order or not, according to this alphabet?
My question was, like, I was trying to clarify the question. Yeah. So when you said that I should return a Boolean value, whether the words in the array is sorted or not, so does that mean that every single word in the array that you have given me, every single word should be sorted according to the new ordering of letters, alphabetical letters that I've given? Every single word should be sorted.
No, that's not the problem. That's a good clarifying question, but the problem is whether you're trying to find whether the entire list is sorted. Like, you don't care about the individual words. So in this case, we the output should be true, right? Because the words are in alphabetical order. H is the smallest alphabet. So high is like alphabetically smaller than mojo, right? Because M is after H in my ordering.
So here, question basically boils down to, I am given an array and I am given a permutation of the alphabetical characters, and I have been asked that whether this array is in the lexicographically smallest order according to this permutation which I'm given of the.
Yeah. So now let's take another example. Like, let's say I'm giving you A, B, C. That is one word, and then F, G, H, I, right? And then I say hello. So is this list sorted in alphabetical order? So ABC, if you compare ABC and FGHI, FGHI comes after ABC according to my definition, right?
Yes.
Right. Yes. But hello is supposed to come first, not at the end, because H is the smallest.
Yes.
Right. Now to take another example, let's say I have right. I have Heli, and then let's say hi, right? So is this in sorted order or not?
E and I. Yes, this is in sorted order.
This is in sorted order, right? Because you're comparing the characters E and I. and then you know that they are in the correct order. So you don't care about the ordering of the characters within each word. You're concerned about the ordering of the words in the list, right? And you want to check whether they are lexicographically sorted. Yeah.
Just for confirming, for the first example, the answer would be true. The second example would be false, and the third would be true.
Yes, that's correct. Yeah. So this will be false. This will be true. Yeah. Okay.
Yes. Can I take a minute or two?
Yeah, sure. So if the problem is problem is clear, then you can go ahead and spend a couple of minutes thinking about it, and then.
Sorry, there's a little background. There's a little background noise. I cannot hear clearly.
Yeah, one second. So I'm saying you can take a couple of minutes, think about the problem, and then we can discuss.
Okay.
Yeah. Just a minute, okay? I'll be back. One second.
Okay.
Hello. Yeah, I'm back.
Yes. One thing I wanted to clarify is there any constraints given in the question? Like, what is the input constraint? Like, how many number of words and what's the
no, there's no constraint on the size of the list.
Okay.
That's such. There's no constraint.
Can I start explaining the solution?
Yeah, sure. Yeah.
Okay. So, so should I first explain? I'm not sure how should I go about explaining. So should I first just explain the logic that I've thought, or?
Yeah. So just you don't have to talk in terms of code. Just tell me at a high level what your idea is for checking whether the list is sorted or not.
So for the first word which I'm giving the order, the permutation of the alphabetical letters, I will first go and find out. And sorry, I'll first go and arrange them. What I basically mean to say is, I will first give them a indexing. By indexing, I mean that
Right.
I will give them a new arrangement. So
yes.
Since I have A to Z, so I'll make an array of 26 length, and I'll give every number its new arrangement according to the new permutation that I am given.
Okay.
And now, according to the new permutation, since I have the arrangement of every letter,
Yeah.
That this thing said that in any case, I got the new permutation in this array of 26 letters. Now,
Yes.
next thing,
Yeah.
the words array.
Yeah.
For that, I'll simply traverse the words array from I
Yeah.
is equals to, I'm considering one based indexing now. So
Okay.
I will traverse the words array from I is equals to 2 to n. And from 2 to n, I'll check for two words at a time. At every single iteration, I will check for two words. So
Yeah.
if I take the example of, if I take the second example here, ABC, FGHI, and HELLO. Hello.
Yes.
Three words I have. I'll
Yeah.
start from the second word,
Mhm.
and I'll end at the third word, which is from 2 to n. In this
Yeah.
case, n is 3.
Yeah.
And I'll at every iteration I'll compare two words, and the two words will be the ith word and the I minus 1th word.
Yep. Yeah.
At every
Yeah.
iteration, what I'll say is if the ith word and the I minus 1th word, the correct order. By correct order, I mean the word the I minus 1th word is lexicographically smaller than the ith word. Then in
Yeah.
that case, I would say that it is that at this index, the word before that is in the correct order. Let us move to the next index.
Sure. Yeah.
So I will do this and continue this up till the last element of the array, which is n. And
Yeah.
for every element, I will check whether the previous word is lexicographically smaller than the current word. If it is true, then I can go to the next iteration. If
Yeah.
in case it is true, in case for every word there is an index, for every word there is a character in that word which does not make the whole word lexicographically smaller than the word next to that, then in that case I would immediately return false.
Yes.
Or
Yeah.
and after that I end the loop, I will return true.
Yeah. Makes sense. And for
Is it
comparing
clear?
two words, how will you do that? Like.
Yes. So since I said in every iteration I will compare ith and I minus 1th word,
Yeah.
and since I also said that I have made an indexed array, so
Yes.
every the 26 letters that I have, every letter stores the index of the new ordering of the alphabets.
Yeah.
So
Yeah.
I will compare according to that. So I'll make a comparator function, and I will check basically what I'll do is for the let's say I'm saying string x, which is the I minus 1th word.
Yeah.
And the string y, which is the ith word.
Yeah.
So I will have to traverse the two strings, and I will traverse in a manner which is I will traverse from the first index to the minimum of the length of the two strings, because obviously I can end at one string.
Yes. Yes.
So I will start from the first index to the minimum of the length of string x and string y.
Yeah. Yeah.
Now, for every element in the string x and string y, since I have called that iterator k is equals to 1 to min of x and y. For every element k, I will check the particular element whether it is less than or whether it follows the lexicographical order according to the ordering that I have given.
Yes.
The ordering that I have mentioned during using that index.
Yes.
And in case it is true, I will simply go to the next position in the same two words that I've selected, x and y. And in case it isn't true, then I'll simply return false at exactly at that point. Because in case it isn't true, that basically means that the first word is not lexicographically smaller than the next word. But in case it is true, that would mean that I would have to check for the next element, and whether the next element is lexicographically smaller or not, it would depend on that. So I will have to continuously check the next element, and in case all the elements are lexicographically smaller than all the elements of the first word is lexicographically smaller than the next word, then I can say that the first word can be accounted for. Then I need to check the next word. So I'll do the next iteration of the loop, of the outer loop. I think I have not expressed that well.
No. I sort of understood what you're trying to say. So we're talking about just comparing two words, right? You're just going to go character by character, right?
Yes.
Yeah. Okay. I think what you can start coding. And like you don't have to explain yourself while you're coding. Basically, like you can go about implementing it, and then if I have any questions, I'll stop you and ask. And if you feel you need to explain something while you're coding, that's also fine. But I would suggest that you write down your implementation. Then we can discuss. Then we can discuss it later once you're done.
Okay.
Sure. Okay.
Can I take a minute or two to think about the code before I start coding? Can I also take some time?
Sure, sure, yeah, yeah. Yeah, I started recording. Can continue coding.
I guess it's clear now. There's no issue right now. No?
Yeah, yeah. Yeah, this is a different platform.
Achha, one thing which I wanted to ask, that all the letters in whatever the string I am given, it's always in lowercase character, no?
Yeah, you're only given the 26 uh, English alphabet character. That's it.
I mean, all of them are lowercase English characters. Like I don't have
Yes,
any
yes, lowercase
uppercase
only. Yes,
character.
yes, yes, lowercase.
Bordering part is done, and now we need to check the data. One thing I wanted to clarify, when you have asked me that ABC is less than FGHI, what would be the
Yeah.
case in which the first string is lexicographically smaller? I'm just giving an example. I just want the output in this case.
Sure.
The example would be ABC and ABC. So I have two strings, and the first string is ABC, and the second string is ABCD.
Okay.
So in that case,
the smaller word comes
ordering
first.
is okay. So when I am considering lexicographically, and what if I do the reverse order? I'm saying ABCD and ABC, and I have two words. So the smaller one should come first.
Yes.
Even though the
Smaller
ordering
word
is
yeah. Smaller word is lexicographically smaller.
okay,
I mean, shorter word is like it's lexicographically smaller.
Okay. I'll just incorporate that also. I guess I've coded the part.
Okay. So can you explain what this count is and why you have this?
Yes. Yes. So now, since I've actually clarified this part just now, that you
Yeah.
said it should, in case I have two words wherein the
Yeah.
prefix is same, wherein there are only last few elements due to the length of the word which are different. Say for example ABC and ABCD. So in this case ABC should be before ABCD. So
Yeah.
what I've done
Yeah.
is I've counted that in case it is equal, in case both the characters are equal, the line number 48. In case both the characters are equal, I'll just highlight that once. In case both the characters are equal, I will do count plus 2. So this will basically count how many characters in the two strings that are taken into consideration at the moment, how many characters in them are equal in the same order. In just a minute. Yes, how many characters in them are equal? By equal, I mean they have the equal ranking. So B and B, C and C, A and A, they both have the same ranking. So they are lexicographically equal. It will just count that, and simply this J loop will what it will do is that for every character it will do so, and it will count how many characters are there in two strings which are lexicographically equal. In case that count is equals to m, which means that in case that all the characters that I'm taking into consideration in the jth loop, in case all of them are equal, basically runs till m. M is the minimum of the two lengths. In case they both are equal, I know that either of the two string is just a prefix of one. I know that of the two strings that there is one string which is just a part of another string. So I will check. In case the length of the first string is greater than the length of the second string, then I can be sure of the fact that even though they are lexicographically, the letters might be lexicographically equal, the length of the first string should be lesser than the length of the second string. Since it is greater than the length of the second string, then I'll have to return false. And in case it is not greater than the length of the second string, it will simply go to the next iteration. It will do I plus plus, just as in line number 33.
Okay. Okay. Yeah, this works. But do you think there's a way to simplify it? Like, I don't think there's a need to maintain another count. I mean, it's not going to like be. It's not in terms of performance or anything. Like I'm just saying the code can be a little cleaner if you avoid using this count variable. Like, can you think of a way?
I'll just think about it.
Yeah. Yeah.
So, I mean, are you asking me that I can avoid the whole thing or I can replace it with something simpler?
Yeah, I mean, I don't think you need to maintain a count of the number of matching characters between the two words. You don't need to do that.
Okay.
So once you've exited this for loop, right?
Which one? Line number?
This line number 40, this for loop that you've written here. If you exit this for loop, it means that you've already exhausted at least one of the words, right? The characters in one of the words.
Yes.
Right? So what does that tell you?
I understood. Yeah. I understood. What I can here do is, since I've exhausted one of the letters, I'll say in which of the string is the letters left? In which of the strings is the letters left? So the string in which the letters is left, that should be the second string, or that should be the yth word.
Yes.
In case it is not true, in case it happens so that the first word has letters left, then I can say that it should return false.
Yes. Yeah. Can you make that code change?
Just comment this part. Okay. Left and I guess this should be here. It is coming out of the loop after all the considerations of the lexicographically smallest. In case it is lexicographically smallest, it will consider the length of the two strings that have taken into consideration at this iteration. And in case the previous string has a length greater than the current string, the exit string has the length greater than the y string, then it will return false.
Yeah, I think this should be okay.
I have one concern. I'm not sure if I should say this or not, but I have just one doubt about the thing that I have myself answered. Should I say that?
Yeah, sure. Yeah. What is it?
So thing is, since I've myself answered this, but the problem is in line number 54-55. Just the thing which I've said now. In case it happens, say for example, I have a word. Let me see once the order. Say for example, yes. I have two words, and out of the two words, the first one has a length greater than the second one.
Yeah.
But the first one is but the first one is smaller. So
Yeah.
I am saying that I have the first word might be of a HLAB, and the second word might be STU. So the first word is greater than the second word, but the
Okay.
first word is lexicographically smaller. In that case, I would have to maintain this count variable.
So what will happen in that? What will happen in that example? So let's take a concrete example just to make it clear.
HLAB and STU. Should I just comment?
Just you can write a comment there saying just x is equal to this, y is equal to this. Just write it.
Okay. X equals to. I have to consider this case. I'm also not sure what I'm saying about. Yes, in case this is the case, I have two elements in the array itself. First element is HLAB and second element is STU. And according to the order that you have given, HLAB is lexicographically smaller than STU. But what this code will currently do is it will go and check up till the first three characters. H is less than S, L is less than T, A is less than U. So it will not return false in the jth loop. It will not return false anything here, and it will come out of the loop. And after that, it will check whether x dot length is greater than y dot length. Here in this case, where I'm taking x and y is this, the x dot length will be greater than y dot length, and it will return false. So what will happen is, even though the x is lexicographically smaller than the y, because lexicographically we first check the elements and then we check the length. So even though it is true that it's lexicographically smaller, it would return false here. So
So what is the bug in your code then? Like what exactly are you doing wrong?
I think that I have to maintain a count variable. Just as you said, the count can be omitted. I don't think that we can omit the count part.
Okay. So are you sure about that? Because let's take a look at your example once again, and then tell me what are the comparisons you need to do to decide that HLAB is smaller than STU.
Okay, just a minute. I'll check that again. HLAB L is less than T, A is less than B. Okay, so what I mean is that this line number 56 and 57 might give wrong result also. So either we maintain a count or we do some other thing to check the length of the two strings. But this line number 56 might not account for all of the cases.
You're right. There's definitely an issue with line 56 and 57. But if you look at your example, HLAB and STU, let's say you compare H and S, right? You know that H is smaller than S.
Yes.
Right. Now, do you need to do any other comparison?
Okay, so you're asking me to simplify.
No. Like forget about what you've written. Just looking at these two words, you want to find out which one is smaller, like lexicographically smaller, right? You compare H and S.
Yes.
Now, do you even need to look at the remaining characters to decide that X is less than Y?
No.
Right? Because no matter what the other characters are, X is always going to be less than Y, right? Because H is smaller than S, right?
Yes, it is going to be lexicographically smaller.
Right. So now do you see where the issue is in your code? So in your for loop, basically what you're saying is, I'm going to keep comparing corresponding characters in the two words as long as I don't find a case where the character in the first word is greater than character in the second word. Right?
Yes.
But the thing is, anytime you find two different characters in the two words, you can make a decision about which one is smaller.
I've understood.
Right?
Yes, I've understood that. And as soon as I find a difference between the two characters, I can take a decision whether it should be returned false or it should return
yes,
true
exactly.
for that particular case.
Yeah.
So should I incorporate that or like?
Yeah, sure. Yeah.
Just a minute. Continue. I'll just have to maintain a boot here. Just to and break. I don't need to check this. And in case, I'll just simple the code or it's too much of comments. Yes. So here it is checking, and in case it will continue. In case it isn't, it will check every letter, and then in that case, it would say check the first and the second string. Whoever length is greater, it might return false. Other than that, it will check. Yes, I think this would work.
Okay, so basically what you're doing is if it's greater than you're returning false. If it's less than, you're setting F1 to true. Why? Can you explain this flag? Wait, what is this?
Yes, yes. So I'm making a flag variable, a bool flag variable, and saying false. So what is happening here is that at every iteration wherein I get the first of the two words x and y uh, at every single index, where at every index, sorry, just at whatever index I get the first character in the first string less than the second string, I would say that FL is equals to 2 and simply break out of the comparison loop that I have, the strings comparison loop that I have. I simply break out of it. And when I break out of that, I have FL equals to 2. And in case I have FL equals to 2, it will do continue. Continue basically means go to the next string and it will not compare the X and the Y, the length of the two strings. That is only the case where I have, wherein I have, it is strictly less than, wherein the order is strictly less. In case the order is equal to at any some point of time, say the order is equal to at every single integer, at every single character of the two strings. So then in that case, FL will never be made equal to 2, and then it will check the length of the two strings.
Right. Yeah.
What I basically mean is I only want to check the length wherein both the wherein all the characters of the two strings are equal. If I find one character unequal, I will not check the length. I will simply give a decision, which I have done here.
Right. You've done a continue. So what this continue will do is basically it will look at the next two words in the list.
Next iteration of the loop, which is I++, line number 30.
Okay, I think this will work, right? If 1, 2, you will continue.
Sorry, your voice wasn't audible.
No, I'm just thinking, I'm just trying to see if it will work in all cases. So you have F1. So you're setting F1 to true only when the character in the first word is smaller than the character in the second word, right?
Yes. As soon as I get a character which is unequal and wherein it's lexicographically smaller, the first one is lexicographically smaller. As soon as I get that, I will say FL equals to true, and I will break out of the loop. That basically means that I can give a decision for this particular two words that I'm considering just at this moment. So I'll break out of the loop. I don't need any more comparisons. And after getting out of the loop, I'm checking whether FL is true or not. In case it is true, that means I don't even need to check the length. I can simply go to the next loop and check the next two words.
Okay. So basically, this this check will happen. We'll check on line 60. I mean, that will happen if the first word is a prefix of the second word. That is the only case in which you will go to line 60, right?
Yes, the first word is a prefix of the second word, or the second word is a prefix of the first word. Whatever be the case, in case both the words have the same prefix, both the words have the same prefix, only then it will go to line number 60 and it will check that the first word should have a length less than the second word. In case it is the opposite, in case the first word has a length greater than the second word, it will return false. It will say, it's not in the
I think this will work. That's fine. So just some. So what do you think is the runtime complexity of your solution, in terms of the length of the list?
Okay, so I'll explain the runtime complexity part by part. So for the first loop, which I'm taking for the permutation of the alphabets, the runtime complexity would be 26 because order.length will be 26 since it's a permutation of all the characters.
Yeah.
For the second loop,
Mhm.
I'm considering the length of the array words as n.
Yes.
So
Yeah.
in this case, the first loop, the for I loop line number 33 would work for big of n, and every
Mhm.
string iteration will take place. So in the worst case, it might be the case that I have to iterate and check every single character of the string in the two strings present. So the worst case complexity would be big of n into m, where n is the length of the array I am given in the input, the words array, and m is the length of the worst case complexity, the worst case length of every string. So it's big
M,
of
right?
n
A number of m. Let's say m is the worst case number of characters in a word, right?
Okay, m. That's what I said. M.
Yeah. Okay, that's correct. Yeah, that's all I had. I think this is good. Yeah, I think we've covered mostly. So at this point, like maybe I'll ask you to do a dry run, like take a few examples and run through your code. But I don't think we need to do that. We've already done that.
Sorry.
Hello, sorry, your voice broke.
That dry run part I heard, and after that, did you say something?
No, you've already sort of walked me through your code.
Yes.
So we don't need to do another. Yeah. Okay. So it looks good. That's all I had. I don't think we have enough time for like follow-up questions and so on. We've already taken up
You
like
can ask me the
40
follow-up
minutes.
questions. I can it will be food for thought to me. I will just try
Yeah.
it later.
Yeah. Okay. So this is a very common problem. I was asked this problem in I think Facebook interview or something. Yeah, I was asked this exact problem. So the extension to this is, let's say I give you a list of words, right? And I want you to find a list of words, like just as you're given here. I'm giving you this list of words in sorted order. I'm going to tell you that the list of words is sorted alphabetically or lexicographically sorted, right? Now I want you to tell me what is the ordering of the characters in this alphabet.
So from the sorted order, the list that you have given me, I want to know what is the new alphabetical order of characters that I have, I have, from which I have derived the sorted order.
Exactly. Yeah, I want you to tell me this ordering, this on line number 4, right? Okay. Given a list of words, and of course the assumption is there is enough information in the list I give you for you to derive the ordering of the characters in this alphabet, right? I give you sufficient number of words. Like just if I just give you hi and mojo, you won't be able to tell me the ordering.
Yes, I understand. Yeah, I understand that.
Yeah. So that's the extension to this problem.
Basically, I have been in this case. I have been given the array, and from the array, I have been given the words array, and from the words array, I want to find the order array.
Yes.
The order string.
Yeah.
Okay. I'll think about that.
Yeah, you can think about that. Like I'll give you a hint. It sort of becomes a graph problem.
Okay.
So you can think along those lines. Maybe that helps.
I think so. It is a topological sort problem.
Yeah, exactly. Sure. Yeah, exactly. It is a topological sorting problem. So once you figure out like how to construct the graph, and all you have to do is do a topological sort, and then you'll get the order.
Yes.
Right?
Yes.
Okay. So yeah, I think we'll end the interview here. And before we do that, I can sort of tell you how you did, right? So I think you started off well. You explained your solution quite well. Like I understood everything. And the good thing you did in the beginning was you asked a lot of clarifying questions. That's very important to do. Clarifying questions in the beginning, right? Okay. Questions like I think you probably asked a lot of questions to understand the problem properly, right? Yes. Many candidates, what they do is once they get the problem, I've seen some candidates who they won't say a single word, right? Once they hear the problem, they'll immediately start writing code. That's really bad, right? So you want to tell the interviewer that you want to let the interviewer know that you've understood the problem correctly and you've thought about all cases, right? So you did that well. You you came up with examples, and then you asked me like what the expected output is for each example, right? So that was good. And you explained your solution also well. Like the solution was, in this case, it was a like straightforward, right? There was no trade-offs. But usually, sometimes in a problem, you'll have trade-offs. Like some problems might have trade-off between time complexity and space complexity, right? That's something you can discuss with your interviewer. In this case, it was relatively straightforward. Like there's only one solution. So you described that well, and then you did well in your coding as well. Yeah, I think your code was fairly easy to follow. So one thing you could have done better was this part of the code, right? Comparing the two words.
Yes.
So one tip is, one good thing you could have done is, this makes sense to split into a separate function, right? So you could have written another like
yes.
yeah, compare words or something like that, right? And then taken.
I usually do that, but I usually do that when I am sort of coding, but I do not know why I have not understood.
Yeah, this is a good, if you do this right, you're that's a good sign. That will be considered as a positive.
Exactly. Modularity of code will obviously make the interviewer also much. It will make it much easier for the interviewer to understand. Yes.
Yeah. So it becomes very clear to me that all of this logic of comparing the two words is in a separate function, and then in here it becomes just a simple call to that function, right? That simplifies the code, right?
Yes.
And the other thing that you could have done better is, instead of doing this, right, comparing less than, greater than, I think it's easy, but there's a way to simplify it even further. Basically, you just keep looping until you find matching characters, right? So the first time you find a mismatch, you break out of the loop, and then you return either true or false, depending on what happens.
Yes,
right?
yes. I understand that it could have been done that way.
So there is still scope to make this cleaner, this part of the code, right? And then you don't need to do this business, right, of having a separate flag. This is generally considered bad. Like if you absolutely need a flag, it's fine to use it, but like try to keep the code as clear as possible, right? You don't need. So this is something you'll only get with practice. I mean, you won't get it right all the time. But if possible, you should try to like simplify the code, right? Then you could have, in this case, you could have avoided this.
I could not hear your voice in like the last 10 seconds. Okay.
Yeah, I think some internet problem, right? So yeah, what I'm saying is you could have simplified this. There was scope to simplify it. So this flag was probably not needed, and then you could have just simply, I think the reason why you did that is because you're using a single pointer to iterate both strings, right? If you had used like I and j and then done it that way, then I think it would have been easier. But yeah, it doesn't matter. It's a minor thing, but just something to keep in mind. If you can simplify your code and make it cleaner, you should always try to do that. And like this happens in interviews all the time, right? So you'll sometimes write some code that doesn't seem very clean. So I think at that point it's good to you can maybe take a couple of minutes, think about what's the best way to implement it, and then do it. Like generally what people do is they just rush into fixing the code and they just mess it up, right? So try to avoid that, right? It's okay to take a couple of minutes, think about what's the best way to implement it, and then you can change the code. You don't have to rush, feel pressure to change it instantly, right?
Okay.
Yeah. So that's what I would say. Otherwise, you did quite well. And yeah.
I would also want to ask some questions. Can you I think what all you had to say, you have said. Can I ask?
Sure.
Can I have some questions?
Sure. Yeah.
I would want that if you could stop recording this part.
Okay. Okay, I'll stop. Yeah.